So, everybody, welcome to the Data Chaos Podcast. This is a special live edition, and I am your host, Tyler Wells. Also joining me today is the co founder and CEO of Propel, Nico Acosta. Nico, thanks for joining me.
Thank you, Tyler. I'm excited to be doing this live session.
And we're here today. We're going to talk about how at Propel we have reduced our Snowflake spend by 20x. Here at Propel, we use Snowflake quite a bit in our infrastructure. We send a lot of data to it. Also, big fans of Snowflake, but as anybody knows that uses it, it can cost you some money. And being good stewards of our investors' money as well as our infrastructure, we're always cost conscious when it comes to our spend. And so we pay a lot of attention to that. And, over the last number of months, we've seen that spend go up, but we needed to do some things to make it come down. And so today we're going to go through all of that. And Nico's going to lead you through the presentation that you should be seeing now. And we'll answer lots of questions and see where we go from here. So, Nico, take it away.
Awesome. Thank you, Tyler. For this, what we would do is a couple of things. So, talk a little bit about our architecture and how we've set up things in Propel. So, one of the principles that we have, the product principles, is that we Propel, we are customer zero. And so we build Propel with Propel. As you said, we send a ton of data to Snowflake. We use that data to power a lot of our external dashboards. So we connect Propel and to Snowflake to serve that data via low latency APIs. So let's walk through first the architecture. What's our setup look like with Propel, with Snowflake, with operationalizing that data again with APIs, and we can dive into our journey of using Snowflake, learning how to use it better, reducing costs, and iterate. Cool. So I think that the first thing to cover is like just a high level. Tyler, if you want to talk about high level our architecture, our event driven architecture that we use at Propel.
Yeah, definitely happy to do that. So, like Nico said, everything we do inside of Propel, all of our services, apps, everything else like that is throwing off events. Different services react to those events. But at the end of the day, we end up streaming all those events onto AWS Event Bridge. And then we use an AWS Event Bridge rule to get that onto a Kinesis Firehose. And then from that Kinesis Firehose, we then send that into Amazon S3, where we then use a Snowflake Snowpipe to take all of that raw JSON data into our Snowflake data warehouse. So all of that data is streaming continuously. It's reacting as our Lambdas, as our Fargate containers, as our customers are interacting with Propel itself, our APIs, the user interface, you name it. All those events are getting generated and ending up on the event bridge, onto Kinesis Firehose, Amazon S3, which then triggers an SQS and then gets picked up by Snowflake.
Awesome. Let's go and look like, what does our Snowflake deployment look like? So essentially take those events from the S3 bucket and pretty much in real time, we use Snowpipe to land them into a raw events table. So we have three databases inside of Snowflake. We have raw, it's the data as it lands from its source. We have staging, that's an intermediate table for transformations that are not designed to be consumed by the business or by applications. And then analytics, that is designed to be consumed by the business or by applications. So here, the thing to note is that that events table is a one column table where we put a JSON event. There's nothing else. Then events deduped unpacks that JSON into its top level keys and dedupes them. So in our event-driven architecture, we have a at least once delivery guarantee, which means if something fails, we can get two of the same events, right? It might go through and then the application might retry it and then you get two events. So once it gets to Snowflake, we need to dedupe those events. Once they're deduped, we start building our models that have like some business meaning, accounts, data pools, and queries, and then we enrich the events with the data that we need. So when we have a query, we'd want to ask, hey, what's the name of the data pool that powered this query, or what's the name of the account that made this query? So we essentially enrich the data in Snowflake. So all of this we do with dbt models, and they're incremental dbt models. Once we have our kind of enriched queries data, we use Propel to service it to our application. So Propel syncs the data into high-speed data pools. We have a semantic layer that can define the metrics of interest for the business, a multi-tenant access control layer, and a GraphQL API, and that's what the application consumes. So that's our setup in a nutshell. And that's useful context as we dive into the problem and the different hypotheses we had about the problem. So what was the problem? It was this. This is our Snowflake credit consumption over time. It was growing more than we wanted it to grow. It was growing like crazy. And we were handling more data, but it still didn't feel right that it was growing at that pace. So we knew there was something going on and that we weren't doing something right somewhere, but we didn't know what it was. So we started, you start poking at the different parts. Our first hypothesis was that JSON unpacking, that Snowflake was inefficient at unpacking that JSON. And let me explain why we thought that. So as I said, the events table in the raw database is a one column table with a JSON payload. The dbt model that unpacked it used a date in a nested field inside of that JSON. So it essentially had to order the entire table of millions and millions of record by the date that was found in a nested field inside of that JSON. So it wasn't crazy to think that that was an expensive operation, more than it needed to be. And I remember discussing with Tyler, like, yeah, this is we need to figure this out, because and our first thought was like, let's unpack it. So we did. So first thing we did here was, you see the snowpipe to create that table. The first one was just a single column table. The second one, we unpack a bunch of high-level keys that we know that are not going to change. So like the AWS Event Bridge event envelope, the Propel event envelope, all these keys are fairly stable. So it's safe to unpack them as early as you can in your pipeline. And we deployed this. And it turns out that we were wrong. It made no difference. So the costs kept going up and up. Snowflake is actually pretty efficient at unpacking that JSON and incredibly querying that JSON and ordering by a key inside of that JSON. So that was pretty impressive. That was the kind of the wrong thing. We still decided to leave it and to unpack, to do that transformation on load. It reduced essentially one DBT model that we had to run. And that was not something that was going to change, given that those two event envelopes are fairly stable. So we went on to our next hypotheses, that our DBT models, our DBT incremental models, were doing something inefficient. And here you will see what our models and our configuration look like. They're materialized as incremental. It's kind of pretty plain vanilla DBT incremental models. And like we looked at this, it's like what can be wrong here? It's like it's do have to say we try to not dedupe and say, okay, maybe we just can't afford to dedupe events and we have to live with it. But obviously that's not an option, right? Having bad data quality is not an option. And once you start seeing the duplicates all over, it's like it's just not something that you can do. So we started digging more into like how DBT handles these incremental models. We did our first experiment here, which is to use the merge incremental strategy and remove the group by in the SQL. If we go back, if you look at the SQL, it has a group by propel event ID that guarantees that we only get one event for that ID. And so can we rely on the DBT merge incremental strategy of merging to dedupe? And what we found was that we can't. On the first, it did not reduce the Snowflake credit consumption. And second, it obviously did not deduplicate. So kind of bad and bad. But we knew we were onto something. It wasn't fully there. So it turns out that Snowflake, when you do an incremental model in Snowflake, it is by default merge. So pretty much the only thing that we did here was to remove the group by in the SQL, which introduced duplicates and like nothing else. So that was kind of a lesson learned. Experiment number 2 is use the merge strategy for the incremental model with what's called an incremental predicate. So what this does is that it merges, but it doesn't merge for the entire table. So if you have, you obviously define the unique key as propel event ID. If there is a propel event ID that already if an existing event ID comes in within 3 hours, it'll replace it, right? And it doesn't have to go and do that for the entire table. So we thought a lot of these times, the context here is important. In an event-driven architecture, if you have duplicates, they tend to be close in time. So we thought a 3-hour window is good enough. And this started reducing our spend, but then we still had duplicates. And I remember I was like, oh my goodness, what is going on? And it turns out that merge, so each batch of the incremental model, say you run it every hour. So for that hour, the new records that come in are not deduped within themselves, right? So if you have 3 duplicate events in that batch, they're going to get merged to the main table. It only merges from the new records to the table to the records that exist, but it doesn't dedupe within the new records. This brings us to experiment number 3, which is change how we deduplicate. So here, if you look at what we did, is perhaps the trick that had the most impact, which you can only do if you have the merge strategy and you have something like what we discussed in the previous 2 experiments, is to move the incremental macro to the common table expression so that it dedupes only the new records. And this is a significantly smaller query than trying to dedupe the whole thing. And with that, we had success. So you see that bump in the red. That's us experimenting on how to do it. And some of these changes, that first bump was the change to the incremental model with the predicate. It helped, but it didn't help that much. And then we were able to squeeze the maximum efficiency of the pipeline. And this is much more what we want to see as operators of platforms, as a which is, and like since then, I mean, we're doubling our volume every couple of weeks, and you see that line kind of being nice and flat. So that's what you want to do. So those are the we wanted to share the tricks we learned both on the Snowflake side and on the DBT side, and just show the effect that they had on our costs and infrastructure. So we're pretty
Well, I mean, I think
confident that we have.
let's say it's a very happy day for Propel, as we were crying tears of
Yeah,
joy of reducing our spend and not burning through our contract for no reason. But I think
yeah.
there was maybe a little unhappiness on the Snowflake side, but probably not.
Probably
We're so
not.
small anyway.
I mean, um, and it feels a lot like uh, kind of the early days of the cloud when uh, when you give a company AWS and then they go crazy and spin all sorts of instances. They leave them running. They do all sorts of inefficient things. It feels a lot like that, right? You just need to be good at managing the resources, the and the um the neat thing is that we have better data. We're pretty confident on our deduplication. We can run the pipeline more frequently, and it costs 20x less, which is pretty neat.
Big success there. So, Nico, one thing I noticed is you showed 2 graphs here that look like Grafana. This is not something I've ever seen in my Snowflake console. Where do these graphs come from, and how did you get such accurate data on our Snowflake spend?
Yeah, that's a great question. So we use Propel. How we do this is we essentially take the query history. We run Propel on top of that table. We bring all that data into a data pool, so it's like fast and responsive, and you can explore it quickly. And then we use the Propel a Grafana plugin to power a dashboard. So a lot of this, we have a pretty comprehensive dashboard that shows all the different usage. We shows the breakdowns by warehouse, by user, by role, by tag. So that was one of the things that really helped us pinpoint. It's like this is this is the model that's being the problem, and that's why we were so focused on that, and we kind of didn't move from it until we solved it. And without that visibility, we couldn't have done this.
Yeah, and it's pretty tough to do if we didn't have this plugin and we weren't getting these events into Propel. This is probably something that would have largely gone unseen, except for we would have seen our credit spend just continue to go up and up and up.
Yeah. And then or you have to go into Snowflake and do those queries yourself, which is not easily uh, kind of integrated with the rest of your observability stack, right? So that's a big, like, when we look at this in Grafana, we look at it just as one. We look at it from like one more observability thing as we monitor our Kubernetes clusters, as we monitor like all the rest of the infrastructure, right? We don't have to go to a special place to look for this. We see this where we see all the other operational data.
And we're using Propel to monitor Propel.
We're using Propel.
That's pretty
Exactly.
cool. That's pretty cool. So where would listeners go to find out more about Propel and learn a little bit more about what's coming up next? Because I think you've got a couple other things we want to share here in the next couple of weeks.
Yeah, absolutely. Um, so a couple of things. We'll put this up on a blog post over the next couple of days so that you have like the exact things that we did, the changes to the DBT models, how we changed our Snowpipe to load, to transform on load. And our next step is to migrate the entire pipeline to use dynamic tables. We want to migrate everything to dynamic tables with the same data freshness. And then the way that we want to do that is doing it as a parallel pipeline, so that we can see what's the cost implication for an equivalent freshness, and versus using the incremental models. Now that DBT supports the dynamic tables as a materialization, that should be fairly straightforward to do. We just need to figure out how to run them in parallel. Say, you can follow us at Propel Data Cloud on Twitter. We'll post our new blogs and stuff there. You can subscribe to our newsletter, propeldata.com/newsletter. We'll share this and other posts that we do, and you can always check out propeldata.com and propeldata.com/snowflake.